Welcome to my class. In past we have already attended multiple classes. Now in the coming series of lectures we will be playing with numbers. So it sounds interesting, right? We will play with numbers. Yes, we will play with 2-digit number today, and in the following class we will play with 3-digit number, and then in the subsequent classes we will check the divisibility of a number by different numbers. So let's get started. First, we will see the expanded and exponential form of a given number. Let's play with a 2-digit number first. So 23, suppose. So how it can be represented in expanded form? 23 means 20 plus 3, and 20 is what? 20 can be written as 10 multiplied by 2, and then it will be 1 multiplied by 3. And in exponential form it will be again written as 10 multiplied by 2 plus 1 multiplied by 3. And 1 is what? If we take power 0 of any rational number, then that becomes 1. So if we choose the rational number as 10, then it can be written as 10 to the power 0, and here 10 we can write as 10 to the power 1. Because if we choose power 1 of any rational number, then it becomes that rational number only. Now suppose if we choose another 2-digit number as 57, then how it can be expressed in expanded form? 57 means 50 plus 7, and 50 means 10 multiplied by 5. So it gives 50, and then it will be 1 multiplied by 7, or simply we can write 7. And on the other side, in exponential form, if we want to express this, then it will be 10 to the power 1, then multiplied by 5, so it will be 50, then 10 to the power 0 multiplied by 7, so it will give you 7, and in total it will be 57 only. Now suppose if we take a 3-digit number, say 235, then how we can represent that? 235 means 200 plus 30 plus 5, right? So it in total it gives us 235. So we have to represent 200, 30 and 5 separately in expanded form. So 200 means we can write this way: 100 multiplied by 2, that means it is 200. Then 30 means we can write 10 multiplied by 3, so that gives 30, and then we can write plus 5. So it will give us 200 plus 30 plus 5, 235. Now let's see how we can express that in exponential form. It will be 235 again. 100 is, we know that it will be the 10 square. So if we take square value or positive exponent 2 and base 10, then it will give us 100. So it can be expressed as 10 square multiplied by 2. Then it will be 10 to the power 1 multiplied by 3, and then it will be 10 to the power 0 multiplied by 5. So it will give us 235. Now let's take another 3-digit number, say 719. So 719 means how much? 700 plus 10 plus 9, that means 790. So now we have to express 700, 10 and 9 separately in expanded form. So 700 means we can write this way: 100 multiplied by 7. Then 10 means 10 multiplied by 1, and then 9. And in exponential form, if we want to express 719, then it will be, or it can be expressed as 10 square. So that gives 100, then multiplied by 7, then it will be 10 to the power 1, then multiplied by 1, then it will be 10 to the power 0, then multiplied by 9. Now if we take 4-digit number, say 40, or let's take 4, 3, 5, then 6, say. So it will be how much? It will be 4000, then 300, then 50, and then plus 6. So 4356. Now we have to separately express this 4350 and 6 in expanded form. So 4000 4000 means it will be 1000 multiplied by 4, then plus 300. So it will be 100 multiplied by 3, then 50. So it will be 10 multiplied by 5 and then 6. So it will be simply 6. Now we will see how we can express 4356 in exponential form. In exponential form, it is 1000 multiplied by 4. So it will be 10 to the power 3, that gives 1000. Then multiplied by 4, then plus it is 100 multiplied by 3, so it will be 10 square, then multiplied by it will be 3, and then 50. So 10 multiplied by 5, so it will be 10 to the power 1 multiplied by 5, and then 6 means it will be 10 to the power 0 multiplied by 6. Now let's take another 4-digit number, say 7038. So 7038 means it will be 7000. Then there will be in hundreds place, there will be nothing. It will be 0 and then 30 and then 8. So 7038. That means when we will express this in expanded form, first we will express 7000. So it will be 1000 multiplied by 7. Then at this place, as we have seen already that there was 0, so it will be 100 multiplied by 0, or we cannot write anything here, and then it will be 10 multiplied by 3 and then plus 8. And if we same number, if we express in exponential form, then it will be 7038. So it will be 1000 then multiplied by 7, then plus 100, so it will be 10 square, then multiplied by 0, or we can choose not to write anything here at this place because it contributes 0 only. Now here it will be 10 to the power 1 multiplied by 3, and then it will be 10 to the power 0 multiplied by 8. So this is how we represent a given number, whether it is 2-digit, 3-digit, 4-digit, or it may be it may be a higher digit number in expanded form and exponential form. So if we generalize this, then it will be, if suppose we choose 4-digit, and then if we represent that as a continuation, so A, B, C, D, and then maybe we have higher digit also on the left of D. So it can be represented as this way. Then it will be plus 1000 then multiplied by D, then 100 multiplied by C, then 10 multiplied by B, and then we will be having A. So this is how we can, or this is how we can generalize the expanded form of a given number of any digit. Then in exponential form, if we represent D, C, B, A, then it will be 10q, then plus 10 square multiplied by C, then it will be 10 to the power 1 multiplied by B, and then 10 to the power 0 multiplied by A. So this is how we represent any given number in expanded form or exponential form. So this is how we can represent any given number in expanded form and exponential form. Next we will see that if we have a 2-digit number and if we interchange the digits and then if we add them or subtract them, then what happens? Now suppose as example, if we take a number 23, so 23, how we can express that in expanded form? It will be 10 multiplied by 2 and then plus 3. Now if we take another 2-digit number, say 47, then how it can be expressed? It will be 10 multiplied by 4 then plus 7. So if we take a general format of a 2-digit number, say AB, then it can be represented as 10 multiplied by A plus B, and this 10A plus B, this format we represent by AB bar. So AB bar, when we will see in mathematics, we will understand that this tells that it is 10A plus B. Now suppose if we interchange the digits of this 2-digit number, means at units place we will have A, and at tens place we will have B. And if we now express that number then how it can be? It will be 10 multiplied by b and then plus a. So actually the number had the format 10a plus b, and when we have interchanged the digits, then it has become 10b plus a. Now suppose if we choose to add these two numbers after interchanging the digits, then if we add these two digit numbers, then what will happen? We will have this as addition. 10a plus b we will get from the first number, and then from the second number we will get 10b plus a, right? Now if we add the a's separately, so it will be 10a plus a, and if we add the b's separately, then it will be 10b plus b. So what will be the result of addition? It will be 11a plus 11b. Now in this addition, in both the parts of this result, we have 11, this as the common factor. So this can be further expressed as 11 then multiplied by a plus b. That means we can conclude here that when we have a two-digit number, and if we interchange the digits of that two-digit number, and if we add those two numbers, then the result of addition will have two factors. One is 11 and the other factor is a plus b. Now, as for example, if we take a number say 47. So 47, how it can be expressed? It will be 10 multiplied by 4 and then plus 7, right? Now if we interchange the digits, then it becomes, the number becomes 74. So 74, how it can be expressed? 10 multiplied by 7 and then plus 4. Now if we add them, 47 plus 74, then it will be how much? It will be 1 to 1. And 1 to 1, how much? It can be further written as, if we factorize 1 to 1, then it will be, if we divide 11 by 11, so it will be 11 only. That means 1 to 1 can be further written as 11 multiplied by 11. So here one factor is 11 and the other factor is also 11. And as per this rule, we have already seen that in the result of addition, one of the factors will be 11 and the other factor will be summation of both the digits. Now here the digits are 4 and 7. So if we add these two digits, the summation will be 11, right? That means one of the factors is 11 and the other factor is summation of both the digits. So that is 11 again. Now again, if we choose another example, say 52, then 52, how it can be written? It can be written as 10 multiplied by 5 then plus 2. And now if we interchange the digits, then it becomes 25. So 25 can be written as 10 multiplied by 2 and then plus 5, right? Now if we add them, 52 plus 25, if we do, then it will be 77. And if we factorize 77, then it will have two factors apart from 1 and 77, which are the two basic factors that any number has. The other two factors will be 7 and 11. So 7 multiplied by 11, or we can write 11 multiplied by 7. So here again we have got one of the factors 11 and the other factor we have here 7. And 7 is how much? 7, 5 plus 2 if we do, then we get 7. So here also this property is getting satisfied, that one of the factors is 11, the other factor is summation of both the digits. Now if we think this way, that we have a number 63 and we want to know that if we add 63 with 36, then what could be the result of addition, and we want to know this result without performing the real addition. So here by looking at the numbers, we can first understand that the first number is 63 and second number is nothing but by interchanging the digits we have got this number 36. So when we will add them 63 and 36, we have learned that the result of addition will have one of the factors 11 and the other factors will be 6 plus 3, the summation of both the numbers. So it will be 9, That means the result of addition will be 99. Now let's take another example. Suppose we have one number 98, and when we will add that with another number which is 89, we want to know what will be the result of addition without performing the addition. So we know when we will add this 98 and 89, basically 89 is the number which we have obtained by interchanging the digits. So it will be, in the result of addition, we will have one factor 11, and the other factor will be how much? Other factor will be, we will be getting by adding these two digits. So it will be 17. So it will be 17 only. So here the result of addition will be 170 plus 11. That means it will be 187. And we can also play in some other way with a two-digit number by interchanging the digits, and that we will see in other class. Next we will see that when we will interchange the digits and if we subtract one number from the other one, then what happens? Let's express one number as AB. So it will be 10 multiplied by A plus B, and when we will interchange the digits, this will become BA. So BA can be expressed as 10B plus A. Now if we subtract one number from the other one, let's subtract BA from AB. So how much we will receive from this result of subtraction? It will be 10A. From the first number it will be 10A plus B, and from the second number it will be 10B plus A. Now if we perform on A first, so it will be 10A minus A, and then it will be 10B minus B. So it can be written as 9A minus 9B. So here it can be further written as 9 multiplied by A minus B. That means what we can conclude from here is when we will subtract this type of two numbers, then the factors of that in that result of subtraction will be, one of the factors will be 9 and the other factor will be the difference of, let's have a number 72, and by interchanging that number, what number we will obtain is 27. So now if we subtract these two numbers 72 minus 27, if we do, then it will be how much? 72 minus 27, so it will be 5, and then it will be 4, so 45. So it will be 45, and as per this rule, 72 can be expressed as 7 multiplied by 10 and then plus 2, and when we interchange both the digits, then the number that we will obtain is 27, so it will be 2 multiplied by 10 and then plus 7. So now if we subtract 27 from 72, then it will be 7 multiplied by 10 minus 2 multiplied by 10, and then it will be plus 2 minus 7. So further it can be written as 10, then 7 minus 2, and then it can be written as minus 1, 7 minus 2. So further it will be expressed as 10 multiplied by 5 and then minus 1 multiplied by 5. So 5 is here common, and then we will have another factor 9. So we finally, the factors that we are getting from that result of subtraction is, one of the factors is 9 and the other factor is 5. And if we take the difference of these two digits, then it will be 5 only. So that is getting satisfied. So whatever we have learned here is getting satisfied. So without doing this much calculation, henceforth we can answer directly. So now if we choose a number, say 62, then from there if we subtract 26, then what will be the result of subtraction? Without doing subtraction, we have to answer that. So 26 and is getting subtracted from 62. So 26 how we obtain? By interchanging the digits of 62. That means when 26 will be subtracted from 62, we know the result of subtraction will have one factor as 9 and the other factor will be the difference of these two digits, that means 4. So it will be 4. That means the result of subtraction will be 36. So this is how we can directly answer the result of subtraction in less time without doing the real subtraction. Now suppose if we choose a number 91, and when we will interchange the digits, then the second number will be 19. So we will perform the subtraction between 91 and 19, and this time we want to answer the result without doing subtraction. So how it can be performed? Since these two numbers have a relationship, and from that relationship and the rule that we have known, here in the result of subtraction it will have two factors, and one of the factors will be 9 and the other factor will be the difference of these two digits, so it will be 8. So it will be 8 here and the result will be 72. Now separately, if we perform this subtraction, if we subtract 19 from 91, it will be 72 only. So this is how we can perform subtraction, by interchanging the digits of a given number and by subtracting the new number from the original number. Now in the next class we will be doing the same thing with a 3-digit number. So with this I end today's class. Thank you.